I know why the cage bird sings. But do I actually? Hey, Vsauce, Michael here, and today we're going to learn about why the cage bird, or any bird for that matter, feels the need to sing. But before we learn why they sing, first we need to understand how it's done. Songbirds learn to perform their songs using a specialized voice box called the syrinx. The syrinx is located where the trachea separates into two bronchial tubes. Each tube is independently controlled, allowing songbirds to produce two unrelated pitches at once, or duet with itself, and make a sound like this. Birdsong is similar to human speech in that it is the product of the carefully coordinated activity of many different muscles. The apparently continuous flow of birdsong is in reality punctuated by brief periods of silence, during which there are short inspirations called mini breaths. These mini breaths allow songbirds to produce longer, sustained notes despite being so tiny. Now that we know how it works, we can begin to understand why. One reason why songbirds sing is to mark their own territory. Despite their beautiful sound, through its song, the songbird is basically proclaiming to the world that this is his territory, and they'll do anything to defend it at all costs. Songs are also sung by male songbirds to attract females. There are also neural correlates of songbirds. Songbirds hold on to the memories of songs they hear during critical periods, usually from their fathers. Songbirds learn their songs during the appropriately named sensory learning phase, where there's the formation of auditory memory. The songs are remembered and stored during the consolidation phase, and then they begin to sing during the sensory motor phase, which is separated into three parts. The subsong is the songbird equivalent of baby babbling. It's unstructured, rambling vocalization with low volume. The plastic song is where song begins to mature, but there are still mistakes and remnants of the subsong still lingering in the vocabulary of the songbird. In the crystallization phase, songs begin to become stable and start to mirror the tunes the songbirds memorized from their fathers. During the sensory motor phase, birds need to be able to hear their own song, as it is crucial for their development. Birds become deaf for any reason, and their songs will also become messed up. Despite not having a neocortex, birds are still able to achieve complex brain function where they can communicate specific meanings to achieve specific goals. They have the ability to make different songs depending on the situation, and other birds can even understand them. They use food calls to ask to be fed or to signal to others in the flock that they have found food. They can also send warning calls to inform members of the flock about an approaching predator. These show the chickens will only make the alarm call when there is another chicken in the area. Instead, it stays silent to avoid drawing attention to itself. This contradicted the original thinking the chicken just made the sound whenever there was a predator in the area. Motivation to sing is regulated in the medial preoptic nucleus and the ventral tegmental area. The roles of dopamine and opioid activity in the medial preoptic nucleus and the ventral tegmental area in male birdsong differ depending on whether the song is used to attract females or is produced spontaneously and undirected. Distinct patterns of dopamine activity underlie the motivation to produce sexually motivated and undirected song. Sexually motivated communications are externally reinforced by opiates released as part of social interactions. Also, increased amounts of testosterone also increase motivation for singing. It makes sense that the males would have motivation and they would also be singing significantly more. The next time someone calls you a bird brain, you can thank them. And as always, thanks for watching.